Okay, welcome to the June 2024 paper 2H walkthrough. Question number 1, we can work out the median because it'd be halfway between 8 and j, so therefore j must be 12. If the mode is 18, then our two k's must be 18, and the range of 13 means that h must be 13 less than 18, which is 5. Question number 2, 3 lines, y equals 2, those are all the points with y coordinate of 2, x equals 6, and y equals x plus 1. You can see there, we label them nicely, and then you can choose a point and test it if you like, see if it works. I've shaded the region we don't want in this, which turns out to be the outside region, that region out there. And that leaves us with the region we do want, which I've labelled R. So your picture should look a little bit like that. Question number 3, we've got 820. I'm multiplying it by a mixed fraction, 9 and 36 sixtieths. You could convert 36 sixtieths into a decimal if you want to, multiply it by that, amongst other ways, either way. 7872 for question 3. Question 4, show that question, so just make sure you show all your workings, writing them both as top heavy fractions, cross cancelling, but making sure it's still visible, so it's obvious I've cross cancelled and it comes out as 8. Question 5, straightforward SOHCAHTOA. Sine of 34 is the opposite over the hypotenuse, so x over 6.5, multiply both sides by 6.5, x equals 6.5 sine 34, which is 3.6 to 1 decimal place. Question number 6, W meters per second. If we convert that into meters per hour by timesing it by 3,600, we get 3,600 W meters per hour, divide by 1,000 into kilometers, 3.6 W. Is the answer we're looking for that one. Question 7 is a compound shape. We have a rectangle and a trapezium. The height of the trapezium is going to be h subtract 13. So a complete equation for the area of the whole shape. I'll start with the area of the rectangle, 13 times 21, and then add the area of the trapezium, that's half the sum of the parallel sides times the distance between them. Do this and you'll find the area of a trapezium, so a half 15 plus 21 times by h minus 13 is 390. Then I simplify everything like so, bring the numerical bits onto the right hand side, and lastly, divide both sides by 18 to find that h is 19.5 centimeters. Question number 8 is a ratios question. We've got a total of 15 parts, 9 to 4 to 2, 9 plus 4 plus 2 is 15. So if I split the 600 between those 15 parts, each part is worth 40. So we have 360 tulips, 160 crocuses, and 80 daffodils. And then I just work out the number of each one of those that are for the yellow flowers. 45% we can times by 0.45. 5/8 we can times by 5/8, and all of the daffodils are there. And then sum those to get 342. Compound interest, 4,500 times by 1.024 to the power of 4, because it's over 4 years, rounded to the nearest karuna, 4948. Question number 9. Question number 10, we've got a pair of simultaneous equations. It does say show clear algebraic working, so be careful not to make too large steps in your solution. I've taken the second equation and doubled it to match up the number of x's, and then I'm eliminating x from the equations. 6y is 15, y equals 2.5. Take the 2.5 and substitute it back into either of the equations. I've chosen the first one. and solve the equation to get x being minus 1.5. So x is minus 1.5, y is 2.5. Question 11, factorising. 11 times minus 2 is minus 22, 11 minus 2 is 9, so it's x plus 11, x minus 2, with the two solutions of x equals minus 11 or plus 2. Question number 12, if we work out the total number of steps for the first 4 days, add that to the total number of steps for the next 3 days, and then divide that sum by the 7 days, we get 12,403 on average. Question 13, cumulative frequencies. Fairly straightforward, just add the next frequency to the total so far, 7, 24, 42, 56, 66 and 70. And then we'll plot those on a graph, remembering to plot at the end points of each of the class intervals. You can see on the screen now where they go. And then draw a line through all of your points, being careful not to miss them by more than half a little square. Not great, but one of my better ones nevertheless. Okay, the interquartile range. So divide 70 by 4, find 3/4 of 70, mark the two lines, read off from the x-axis. I get 36 and 17 as my two distances, so that's 19 kilometers as my interquartile range. Anything between 18 and 22 is acceptable. And then for part D, draw a line up at 46. It comes out as 63 on my graph, and so that's 7 in total. Although if you got 6 or 8 or 9, that would have been acceptable for question D. Question 14, expanding. Pick any of the three expressions and expand them. If you expanded the double brackets first and then multiplied all the parts by 3y, that's absolutely fine. I've done 3y times 2y plus 5 first, and then multiplied each part by y plus 7, and then collected the like terms, so grouped together the y squareds, leaving us with 6y cubed plus 57y squared plus 105y. For the fractional equation, I've just gone for a common denominator approach of all three fractions. That's not the only way of doing this one. You could have done it in a few different ways. Anyway, the first fraction, I've multiplied the top and bottom by 20. For the second one, I've multiplied the top and bottom by 25. And therefore, everything is written over 100. Actually, I can just multiply everything by 100 here and get rid of all of the denominators. Collect the like terms, bring the non-x's onto the right-hand side and divide by 190 to get that x is equal to 1.2. Okay, question number 15. We have to make g the subject. First step is to square both sides. Gets rid of the square root from the right-hand side. I'm going to multiply both sides by 11 plus 2g. And expand it out in one step. So 11e squared plus 2ge squared is equal to 7g plus 5. Then I'm going to bring the g's onto the left-hand side and non-g's onto the right-hand side. Factorize out a g from the left-hand side. And then I can divide both sides by 2e squared minus 7. To get that g is equal to 5 minus 11e squared over 2e squared minus 7. Should be a g equals there. For b, solving the quadratic inequality, I factorize first of all, and that gives me my two critical values. Those are 8/3 and -4. Now we want the part of the graph that is above the x-axis, so that's to the right of 8/3 and to the left of -4. So my solutions are going to be y is less than -4 or y is greater than 8/3. We need to write that as two separate inequalities. We can't join them together because it wouldn't make logical sense. Alright, for the Venn diagram, we know 9 goes in the middle, and then we can work out what's on the outside. So the intersection of k and p must have an 8 as well as the 9, and you can just build it up step by step by working out what's left. It tells us that 2 is on the outside, and lastly, we know there are 60 in total, so a 7 will go in there. It's given that the student chooses photography, so we're out of 28, and 17 of those choose knitting, so 17 28ths. There are 11 in P intersect K complement, and 28 as a number of elements in P union E intersect K. For question 17, proportionality, Q is proportional to the square root of D, therefore Q is equal to K times root D. Substituting in the values they give us, the square root of 324 is 18. Divide both sides by 18, we can work out that K is equal to a quarter or 0.25. Therefore, the equation is Q is equal to a quarter times by the square root of D. For question 18, first thing to do is to work out the gradient of P. So I'll bring the 2x onto the right-hand side, divide both sides by 5, write it in mx plus c format. We can read off the gradient as being negative 2/5 for the gradient of P. So little thing there, perpendicular symbol, I don't know if you've seen that before, but the perpendicular gradient is equal to the negative reciprocal of that, which is 5/2 in this case. Question 19 is the upper and lower bounds question. The upper bound of C will be 8.5, the lower bound of C will be 7.5. For F, the upper bound of F will be 6.625, and the lower bound of F will be 6.615. For H, upper bound of H, 1.25, lower bound of H will be 1.15. Then we want the lower bound for G. Now, to get the lower bound of G, essentially we're trying to make this as small as possible. So we want the numerator to be as small as possible, and we want the denominator to be as large as possible, because we're dividing by it. So if we take the upper bound of F, it makes it larger. If we take the lower bound of H, it makes it larger, because we're subtracting the H. And then substitute in the values we have there. So 7.5/2 times 6.625 minus 3 times 1.15 comes out as 0.765. Question 20. So 5k over x plus 2. First thing I'm going to do is replace the k with x minus y. And then I'm going to replace the x's with 1/4y. Then I'm just going to tidy up the numerator here by expanding out the numerator. So 5/4y minus 5y at the top. And then the denominator is unchanged, 1/4y plus 2. Now the key to unlocking this one is to multiply by the fraction 4y/4y, which is a legitimate step because that fraction is equivalent to 1. But when I multiply the numerator by 4y, it cancels with the 4y that's in the denominator of the fraction that's in the numerator, leaving us with 5. And then 5y times 4y is minus 20y squares. And then similarly with the denominator, we get 1 plus 8y. So 5 minus 20y squared over 1 plus 8y. Alright, the shaded area of the circle inside the square is going to be the area of the square, subtract the area of the circle. I am going to call the radius of the circle little r, which means that the side length of the square is going to be 2r. So we've got an r going across there and an r going down. So all the side lengths of the square are 2r. So to find the area of a square, we will square the 2r, so 2 lots of r all squared. Subtract the area of the circle, pi r squared is equal to 80. It gives us that in the question. Simplifying 2r all squared to get 4r squared minus pi r squared equals 80. I'm going to factorise out an r squared from the left-hand side. And then divide both sides by 4 minus pi and square root it, and that will work out r. If you worked out r, that's absolutely fine. You could leave it then as an uncalculated expression, or if you calculate it and you use the answer function in your calculator, that's absolutely fine. Anyway, the length AC using Pythagoras is the two side lengths of the shorter side lengths are going to be 2 lots of r, where r is the number we've already calculated. When you plug all that into your calculator, it comes out as 27.3 centimeters for the diameter of the square. All right, question 22. So we have simultaneous equations here. Of course, when you solve simultaneous equations, it finds the points of intersection on a Cartesian plane. First step, I'm going to take the linear equation and make y the subject. You could have just as well made x the subject. That's absolutely fine. You'll end up with the same set of answers if you do it correctly. Substitute y for 5 minus x in the nonlinear equation, and then expand out 5 minus x squared to get 25 minus 10x plus x squared. Multiply each part of that by 3. And we're dealing with a quadratic equation here, so we want to create a 3-term quadratic equal to 0. Let's group together the x squared terms. We've got minus 30x, bring the 210 onto the left-hand side, and we have a 3-term quadratic equal to 0. Everything's divisible by 5, so I'll divide it by 5. That factorises quite nicely, but if you've used the formula or completed the square, that's absolutely fine too. Either way, you get x equals minus 3 or x equals 9, and the corresponding y values are going to be y equals 8 and y equals negative 4. So our coordinates of intersection are minus 3, 8, and 9, negative 4. Question 23, playing about with indices and prime factors. First thing I'm thinking with this question is we've got a lot of powers of 5 going on, not least in the answer. So I'm going to try and write everything as a power of 5 where I can. 30 is 2 times 3 times 5. The 25 is 5 squared, so I've replaced 25 with 5 squared. 180 is 2 squared times 3 squared times 5, so I'm going to raise that to the power of a half because of the square root. And the square root of 5 is 5 to the half. And then I'll leave the rest of that alone. Then we're going to start simplifying now. I'm just playing about with indice rules. So the 2 times 3 times 5 is fine, times by 5 squared to the power of 2x plus 7, just times 2 by 2x plus 7. And for the denominator, raising each part to the power of a half, we get 2 times 3 times 5 to the power of a half, and then times by 5 to the power of 2x plus 4.5 or 9 over 2. The 2's and the 3's cancel really nicely, and so we can just apply the indice rules to the numerator and the denominator. So I'm going to add 1 to the power of 5 in the numerator. I'm going to add a half to the power in the denominator, and then finally carry out the subtraction of the powers, leaving me with 5 lots of 5 to the power of 2x plus 10. For the vectors question, A to C, my path from A to C is to go from A to D, A to O, and then O to B, and then B to C. A to O is minus 4A, O to B is 3B, and then B to C is 2A plus B. Collect those together, minus 2A plus 4B. Or if you put 4B minus 2A, that's absolutely fine. Okay, for part B, this is the trickier vectors question. We've got to find O to Q. Q is this point that is sort of the meeting point of the extension of O to P and the B to C that meets outside to the top right of the shape. My first way of finding O to Q is saying, well, it's going to be a multiple of O to P. So I'm going to call it lambda lots of O to P. I know that lambda is going to be a number greater than 1 here because O to Q is longer than O to P. The vector from O to P, I'm going to calculate the path as O to A plus A to P. We know that A to P is 3/5 of A to C because of the ratio it gives us in the question. A to P to C is 3 to 2. So A to P is 3/5 of A to C. O to A we know is 4A. A to C we calculated in part A. So we're going to get 3/5 of that vector, and it's lambda lots of all of this because this is our vector O to P we're calculating here. I'm going to expand out the brackets now. This is just sort of a bit like algebraic simplification, and therefore we're going to have lambda lots of 14/5 A plus 12/5 B. Expanding the lambda out this time to get a full vector for O to Q in terms of lambda. We've got 14/5 lambda lots of A plus 12/5 lambda lots of B, and that's my O to Q in the first way. The second way of going from O to Q is actually slightly simpler than that one, I think, is to go from O to B and then from B to Q. Vector O to B we already know, and we know that B to Q is going to be a multiple of B to C. So I'm going to replace B to Q with mu lots of B to C, where again mu is it's just a proportion. It's going to be a number greater than 1. O to B is 3B, B to C is 2A plus B. If I expand that out, we get 3B equals 2 mu lots of A plus mu lots of B. And then lastly, I'm going to factorize that. So we've got a multiple of little a and a multiple of little b. So 2 mu lots of little a plus 3 plus mu lots of little b. Now we can compare the two vectors we've constructed because the number of little a's and the number of little b's will be the same. So we know that 14/5 of lambda must be equal to 2 mu. Or if you prefer dividing both sides by 2, mu is equal to 7/5 lambda. We also know that 12/5 of lambda must be equal to 3 plus mu from comparing the b's, the little b's, in both vectors. And because we have mu is equal to 7/5 lambda, I can replace the mu with 7/5 lambda, and it gives me a little equation we can solve to find the value of lambda. Subtract 7/5 lambda from both sides, and you get lambda will be equal to 3. Then we just need to substitute that into our expression for O to Q from the first way. Plugging lambda equals 3 in, we get 42 over 5 lots of little a plus 36 over 5 lots of little b. And that's our vector O to Q. For 25, you could just sketch the graph if you want. Anyway, the point A is going to be at 32. Because the amplitude is twice as big, and B is at 300, 0. Well done. Bye.